Hello everyone from Math 1435, Pre-Calculus 2. It's Professor Wenson here again with a video on your KnewtonAlta homework for section 7.4 part 1, titled The Other Trigonometric Ratios on the Unit Circle. So we've seen how to determine the sine and cosine of an angle using the unit circle. And reference angles. We saw reference angles before. This section here this part 1 is doing the same thing, but for the other four trigonometric ratios. Cosecant, secant, tangent, and cotangent. So first before I get into the assignment, I just want to refresh your memory as to what the unit circle looks like and how we're going to use it. So I'm just going to make a quick rough drawing here, making the unit circle. Remember, the unit circle is just a circle with a radius of 1 centered at the origin. So we got, this is the point 1, 0 over here, the point 0, 1, negative 1, 0, and 0, negative 1. All these points I've just drawn are supposed to be a 1 unit away from the origin. Alright, and then when we draw an angle, an angle in standard position, meaning I'm starting from the positive x-axis, I draw some angle, again say it's angle T or theta or whatever you want to call it. Sweep out some angle. I started here at the point 1, 0, and I sweep out some angle, and I get the terminal side of my angle, and I end at some point on the unit circle. And let's call this point, it's going to have an x coordinate, say x, and a y coordinate called, let's call it y. And you've seen me draw this picture in a previous video, where if I now take this point on the unit circle, I can create a little right triangle with my angle as one of the acute angles in the right triangle. I just draw a perpendicular segment to the horizontal axis, to the x-axis. And if I do this, I create a little right triangle here with these side lengths. This is a radius of the circle. The hypotenuse of the right triangle is a radius of the circle, which is 1 unit. And this length here is simply the x coordinate of the point. This length here, the vertical length, is simply the y coordinate of the point. And we had the following relationships. We saw that the cosine of my angle, the cosine of t was just adjacent over hypotenuse, x over 1, or just x. Remember this from earlier, hopefully. Remember, the cosine of your angle was just related to the x coordinate of the point that you stopped at on the unit circle. So back up here, if I can write the coordinates of this point in another way. The x coordinate is the cosine of the angle that got me there, the central angle that got me there. And then the same thing went for the sine. The sine of angle t here, opposite over hypotenuse. Remember, sine y over 1 or just y. So on the unit circle, the y coordinate of the point you stop at is just the sine of your angle, the sine of the central angle that got you there. So the coordinates of this point I could rewrite as cosine t for the x, sine of t for the y. And again, this is only for points on the unit circle, 1 unit away from the origin. Alright, so we saw these last time, in the last couple videos. So the other four are found in a very similar fashion, just with the same picture. So remember tangent, right? The tangent of t, looking at my right triangle here, remember the tangent was the opposite length in a right triangle divided by the adjacent. So for this angle t here, the opposite length is y, the adjacent length is x. So this is y, whatever the y coordinate of the point is, divided by whatever the x coordinate of the point is that I land on. Okay. And then you have the reciprocals of these, right? We've seen there are 6 trig functions, 6 trig ratios. All right, so I'll put these over here. Remember the reciprocals. I'll write reciprocals. Remember the reciprocal of cosine was called secant, S-E-C, abbreviated. Right, so if the cosine of t is x, right, x over 1, then the secant of t is 1 divided by x. Right, 1 divided by the x coordinate of the point that you land at on the unit circle. And remember that's hypotenuse over adjacent. Right? If you look at angle t here, hypotenuse over adjacent. The reciprocal of the sine of t. Remember the reciprocal of sine was called cosecant, CSC abbreviated. Right, so the cosecant of angle t, right, if the sine of t is y, or y over 1, flip that over, 1 over y, right, 1 divided by y, would be the cosecant of t, and that's hypotenuse over opposite. And finally here, the last trig ratio, the tangent of t, right, remember the reciprocal of the tangent is called the cotangent, and that was abbreviated COT. And if the tangent of t is the y coordinate divided by x coordinate, the cotangent of t is the x coordinate divided by the y coordinate, or in my picture here, that's adjacent over opposite. All right. So now we're just adding these on. Okay, just adding these on. All right. So if we know this, and also remember how to use reference angles. Right? Remember how to use reference angles. I'll bring up a picture with those as well. Right. So say my angle ended in some other quadrant. Right. Remember reference angles. I'll say using reference angles. So again, here we have the unit circle. Draw a similar picture. 1 0 0 1, negative 1 0 0 negative 1, and again all these points that are 1 unit away from the origin. And I draw some angle in standard position. It's just always, always when we're drawing our angles in standard position, we start from the positive x-axis. And this time I'll just say I draw it, say it ends in quadrant 3. Remember the quadrant numbers, right? Quadrants 1 in the upper right corner, and then it goes counterclockwise. 1, 2, 3, 4. Right? So say my angle here ends in quadrant 3. Right, so here's angle T again that I just drew. And again, it ends at a point on the unit circle, say x, y. Now remember the reference angle. The reference angle is formed by the terminal side. Right, so here's the terminal side, right? The side where the angle ends, and the horizontal axis, the x-axis. So the reference angle here is this angle right here. All right, and if this is called T, remember the reference angle in this particular book was being called, T prime. Right, it was just the same name of the angle, but with an apostrophe above it. All right, And the reference angle, remember, was always an acute measure, right? Something between 0 and 90 degrees, or between 0 and pi over 2 radians. Right, and then you just had to pay attention to what quadrant you were in. All right. So hopefully you recall these rules from last time. So remember, the cosine of an angle you can find by instead of taking the cosine of this angle, you can take the cosine of the reference angle t prime and then make that positive or negative depending on the quadrant. Right? Remember this plus or minus here depends on the quadrant. Because if your angle's in quadrant 1, the cosine will be positive. If your angle's in quadrant 3, like this picture, the cosine will be negative, right? So you have to, you take the cosine of the reference angle and then make that cosine of the reference angle positive or negative depending on the quadrant. And the same thing goes for all the trig functions. The sine of an angle, well, you can take instead, you can take the sine of the reference angle and then make it positive or negative depending on what quadrant you're in. And the same thing goes for all 6 of them, right? The tangent of an angle is just the tangent of the reference angle t prime, but positive or negative depending on, and again, you got the other 3 as well, depending on what quadrant you're in. All right, so just a refresher, remember cosine is related to x coordinates. You saw that on this page, right? Cosine is, the value of cosine is related to the value of the x coordinates. And the value of sine is related to the value of the y coordinates. And the value of tangent is related to the division of both, right? It's y divided by x. So if you keep this in mind, you can say that you can see what trig functions will be positive and what trig functions will be negative in certain quadrants. And I'll point that out here. All right, in quadrant 1, all trig functions are positive up here. All right. All trig ratios, all trig functions are positive if your angle ends in quadrant 1. If the angle ends in quadrant 2, see, in quadrant 2 the x coordinates are negative, so cosine will be negative, and if cosine is negative, so will secant, right? Because secant is just the reciprocal of cosine. But you see, so I have again negative x coordinates, positive y coordinates. So the only trig functions that are positive in quadrant 2 are sine and cosecant, its reciprocal. So sine, right, sine and cosecant, right, the reciprocal, are positive, and that's it. They're the only positive trig functions in quadrant 2. Everything else is going to be negative. Alright. So, so cosine, secant, tangent, cotangent are all negative in quadrant 2. Quadrant 3, you have negative x coordinates, negative y coordinates. Alright. So if x coordinates are negative, that means the cosine's negative, secant's negative. Y coordinates are negative, so the sine is negative, and cosecant is negative. But remember, when you do tangent, you're dividing those, right? When you do the tangent, you're dividing the y coordinate and x coordinate. And a negative divided by a negative will be positive. So in quadrant 3, tangent and cotangent are positive, and everything else is negative in quadrant 3. All right. And then finally in quadrant 4, right, you have positive x coordinates, right, to the right of the center, but negative y coordinates. So the only functions that are positive down in quadrant 4 are cosine and secant, right? The ones related to the x coordinates. So cosine and secant are the only trig functions, trig ratios that'll end up being a positive value. All the other 4 will be negative. All right, so everything, all the functions are positive in quadrant 1. Only sine and cosecant are positive in quadrant 2. Only tangent and cotangent are positive in quadrant 3. And only cosine and secant are positive in quadrant 4. Now there might be a little acronym here. That's why I double underline some of these letters. I've heard some, there's the A, S, T, C to let you know which functions are positive. All sine and its reciprocal, cosecant, tangent and its reciprocal, cosine and its reciprocal. I've heard, all students take calculus, or all smart trig class, or something like that. All right, I think in the book, in your KnewtonAlta instruction, it's all smart trig class, but going counterclockwise. Or from the lower right, you got cast, right? The word cast, C-A-S-T. However you want to remember that, just please remember so that you know which sign to use when you take the value of the trig function at the reference angle. All right, and this is what I'm going to be doing for most angles. Is when you're given the cosine of an angle or sine of an angle, find the reference angle. Find the value of the trig function at the reference angle first, and then pick plus or minus depending on what quadrant you're in. Okay. All right. So hopefully that was a nice. Now again, that was basically a refresher of what we've seen in previous sections. Just now we have the tangent, secant, cosecant, and cotangent introduced. All right. So here's your. Again, I'm seeing the word preview. You're not going to see the word preview. There are only 2 objectives here. You got your mastery bar and all that. Again, you're probably familiar with these by now. So this objective is using reference angles to evaluate secant, cosecant, tangent, and cotangent functions. Now, I didn't bring this up earlier in the video because you should know these by now. Remember there are some special angles. Special angles are multiples of 30 degrees, 45 degrees, 60 degrees. All right, or pi over 6 radians, pi over 4 radians, pi over 3 radians, if you put those angle measures in radian measure respectively. You should know the sine and cosine of those angles by heart. All right, I asked you to learn those, the sine and cosine of 30, 45, and 60 degrees. Because if you know those, right, if you know the sines and cosines of those special angles, and you got your unit circle stuff down, this shouldn't be a problem. Right? Finding the other 4 shouldn't be a problem. So I'm just going to do this now. You can click on more instruction. I know I usually say if you see an objective for the first time, click on more instruction. I kind of just went through the instruction here with my picture of the unit circles that I drew earlier in the video. Yeah, so you can do that if you want, or if hopefully before you started this, you read section 7.4 in your OpenStax book, and maybe practice some problems there, watch some videos, and took some notes on the reading and the videos, and organized those notes. And hopefully you've prepared. But if you're still unprepared, if you're still unfamiliar with the material, I would click on more instruction. Okay. So here, in terms of the cosecant of a positive acute angle, so they want the angle in here in the answer to be a positive acute angle, right? Something between 0 and pi over 2 radians. What is the expression for cosecant of 3 pi over 4? And you see it says to enter the angle in radians. All right, so I'm going to go to some paper here for you, and we're asked to find, right? We're asked to express the cosecant, right? The cosecant of 3 pi over 4. All right, so the angle here, I'll call it theta this time. The angle that we're talking about is this 3 pi over 4 measure. Or if you'd like, you can change this to degrees, right? But remember that they want us to enter the final answer, the angle in radians. But this is, pi over 4. Remember, pi over 4 is 45 degrees, and 3 times that is 135 degrees. So I'm going to draw this. And again, I'll put up like, here's the unit circle. I mean, you don't have to have the unit circle really for this one, but let's see. Alright, so I'm going to draw standard position starting from the positive x-axis. I'm going to draw 3 pi over 4, 135 degrees. So this is 90 degrees, and then I need another 45. So that's like halfway into quadrant 2 here. Alright, there we go. So here's here's theta. Here's 3 pi over 4. 3 pi over 4 radians. Now, what's the reference angle? Right, the reference angle, remember, is the angle formed by the terminal side and the horizontal axis. So this angle, it's always acute. Right, this angle here, this is theta prime, right? The reference angle. And if you think about it, right? Remember, 180 degrees is pi radians. Right, if you go halfway around, that's pi radians. So 3 pi over 4 plus another pi over 4, another 45 degrees. Right, so the reference angle is pi over 4, right, and I'm in quadrant 2. I'm in quadrant 2, where, remember, the x coordinates are negative, cosine is negative, and y coordinates are positive, so sine is positive. All right, so this cosecant of 3 pi over 4 will be equal to, and I'm going to take the cosecant of the reference angle. The reference angle is just pi over 4. And then is it plus or minus, right? Then I choose a plus sign or a minus sign here. Now what quadrant this is in? Quadrant 2. Remember, the sign will be positive in quadrant 2 because the y coordinates are positive. All right. And if the sign is positive, then its reciprocal, which is the cosecant here, will also be positive. So this is positive because, again, this angle is ending in quadrant 2. So the cosecant of 3 pi over 4 is equal to positive the cosecant of pi over 4. Right. Now to find this, again, very easy. Let's recall here. Remember the sine of pi over 4? Now if you don't, please go back and watch other videos or read the previous section, section 7.3. Remember the sine of pi over 4, the sine of 45 degrees. Remember, this is the sine of 45 degrees. That was the square root of 2 divided by 2. Or, 1 divided by the square root of 2. Same thing. Right. So, the cosecant of pi over 4 is the reciprocal of this, just the square root of 2. So up here, the cosecant of 3 pi over 4 is positive cosecant of pi over 4, and the cosecant of pi over 4 is the square root of 2. So this is positive square root of 2. The cosecant of 3 pi over 4 is the square root of 2. Now I'm going to pull a calculator up and we'll verify this. All right. So again, when I turn my calculator on, I want to make sure, now all my angles here are in radians, so I'm going to make sure I'm in, see I'm in radian mode, hit the mode button. So far I'm in good shape. Now, pardon me. To enter the cosecant, there is no, on the 8384, there is no cosecant button. There's only sine, cosine, and tangent. But you just have to remember that cosecant's the reciprocal of sine. Right? So if I want cosecant, I go 1 divided by the sine. All right, that'll give me cosecant. And then in parentheses, 3 pi divided by 4. Right? They're my radians. And I get, see, 1.414. Now let's see if what I said here in this line was correct. It should be equivalent to the square root of 2. Let me type in the square root of 2 here. And it's exactly the same value. Right? So this was correct, right? Using the reference angle. Now, they didn't ask for the square root of 2 in the assignment. Right? You see what they asked for was, do I use a plus or minus sign? And what's the reference angle? Right? You see back here. Right? Do I use a plus or minus? Right? I guess I don't know why I'm doing that. I don't want plus or minus. I guess I don't think I need to enter anything. I guess if I put a plus, we'll see if the plus. I just hit shift and there's a the equal sign has a plus sign above it. Let's see if that actually if it takes the plus sign. Because usually you don't write a plus sign, right? If something's positive, usually you don't write anything. And then you have the reference angle, right? And here I want the reference angle for 3 pi over 4. That's pi over 4. Right, pi divided by 4. I'll see if it takes the plus sign. Yes, it does. Right. Again, the plus sign. Okay, I guess you didn't need to put it, right? Because normally, you've seen this in algebra, right? Normally, if something's positive, you don't need to put a plus sign in front of it. But they are also accepting the plus sign. All right. But yeah, so a plus sign because you're in quadrant 2, and cosecant would be positive. And then the reference angle for 3 pi over 4 is pi over 4. All right. Same as last section, just with different trig functions. All right. Now this objective is find the value of the secant, cosecant, tangent, cotangent values for angles in the first quadrant of the unit circle. So again, I showed you a unit circle before. Let's do it again, right? Again, you can click on more instruction. I've already kind of gone over the instruction on a piece of paper with you. So I'll just do the question. All right. So what is the value of the cotangent of theta if the terminal side of angle theta intersects the unit circle in the first quadrant at x equals 15/23? And then enter your answer as a fraction. All right, so let me draw what they're saying there. Let me draw what they're saying. So I'm going to be doing this a lot, right? So again, a very rough sketch of a unit circle. So 1 unit there, 1 unit there, 1 unit there, and 1 unit there, -1, right? So all these points, right, are 1 unit away from the origin. Now they're saying we have an angle called theta that ends in the first quadrant. So that could be a clockwise angle, a counterclockwise angle, as long as it ends in the first quadrant and intersects the circle at x equals 15/23. So 15/23, it's a little more than a half, right? That's say 15/23. Say that's where, again, this is x equals 15/23. So we're talking, what points on the unit circle have an x coordinate of 15/23? So say this point here, and also this point down here, right? Both those points on the unit circle have an x coordinate of 15/23 and some y coordinate, right? I don't know the y coordinate. Right, that is unknown to me right now. All right, so we're told that we have an angle, theta, that ends, right, its terminal side has this point on it in the first quadrant. All right, so here's an example of an angle theta that they're talking about. All right, always drawn from the positive x-axis, and it ends at a terminal side that intersects the unit circle at a point where x is 15/23. All right, so you see the little right triangle here? All right, hopefully you see the right triangle. Or take the point, I draw a segment perpendicular to the x-axis, and you got a nice little right triangle here. All right, so we already see, hopefully you already see that this side has a length of 15/23. This side I'm trying to find, right? That'd be the y coordinate of my point, and then it's the unit circle. So this has a hypotenuse of 1, right? The hypotenuse is a radius of the circle. All right. So let me first fill in this point. What is the y coordinate? And that's using the Pythagorean theorem. All right. If I look at this right triangle, we'd have 15/23 squared plus y squared should be equal to 1, right? The hypotenuse squared, 1 squared, or just 1. Okay, so 15/23 squared, that's 15/23 times 15/23. 15 times 15 is 225. 23 squared is 529, I believe. Let me see. All right, don't want to do too many things in my head and ruin everything. 529. Okay, so we have 225 529ths plus y squared equals, and then over here the 1, because I have a fraction, I'm going to make this have the same denominator. So 1 is 529 529ths. That way there's a common denominator. All right, and then I'll subtract. Right, so we have y squared equals what's 529 minus 225? That'd be 304. Right, because and then over the common denominator of 529. All right, and then I don't believe 304 has a nice square root. So y is going to be the square root. It's plus or minus. So like you see, this point up here would have the positive coordinate, and this point down here would have the negative coordinate, right? This is technically plus or minus, but I'll just not write the minus. Square root of 304 divided by the square root of 529 we already saw is 23. All right, so this is the square root of 304 divided by 23. That's the y coordinate of this point. All right, now we're asked to find the cotangent. All right, we're asked to find the cotangent of theta. All right, find the cotangent of theta. Now, if you recall from earlier, right, I remember I drew this picture at the very beginning of the video. If you're stopping at a point on the unit circle, the x-coordinate of that point is the cosine. The y-coordinate of that point is the sine. And the y divided by the x is the tangent, meaning that the x-coordinate divided by the y-coordinate on the unit circle here is the cotangent. All right. So remember, this is equal to the x-coordinate of the point on the unit circle that we stopped at divided by the y-coordinate. So that is here, that's 15/23 in the numerator divided by, and then the square root of 304 23rds in the denominator. And can you see if I multiply the top and bottom by 23, the 23's will cancel. So I have 15 divided by the square root of 304. All right, and I think they'll take it that way. Pretty sure. Let me just double check, make sure the square, I guess we could factor and stuff, but let me see if the square root of 304 is actually a nice number. It is not. All right. So I'm going to leave it this way. All right, it just says enter as a fraction. So going back here, so let's see what happens. I got 15 in the numerator divided by the square root of 304. And I guess you could rationalize the denominator if you wish, but I'll see if it takes it this way. Beautiful. All right, so it does take it that way. Let me go through the same stuff and show you. Remember, cotangent's x over y if you're at a point on the unit circle. Right. Wonderful. All right. So here, use a reference angle to write the cosecant of 295 degrees in terms of the cosecant of a positive acute angle. All right. So back to my paper. You might notice the repetitive nature of this, right? Drawing lots of circles and whatnot. So again, no harm in this. I'm just gonna start off with. Now we might not even need the unit circle here, but I'll just draw it. What the heck, doesn't hurt. We're asked to find, the cosecant of 295 degrees, right? We're asked to write this in terms of the reference angle, right? All right. So my angle here is 295 degrees. I'm going to draw that. All right. So again, so theta. I'll call it theta. 295 degrees, or if you want to change that to radians, that's fine too. So starting from the positive x-axis, this is a positive 295 degree angle, so it means I'm going counterclockwise. Remember negative angles go clockwise. Just keep that in mind. I haven't seen any negative angle examples yet. All right, so this is 90 degrees, 180 degrees, 270 degrees, and then 360 is too big, and then that's 270. I need to get to 295. So 270, I would add another 25 degrees here, and looks like we're ending in quadrant 4. Right. And what's the reference angle? So here's theta, right, 295 degrees. What's this angle here, right? This is theta prime, the reference angle, the angle formed by the terminal side, right where it ends, and the horizontal axis, always acute. So what's theta prime? What's the reference angle? Well, this was 295, and all the way around is 360. So this is 65 degrees, right? Because 295 plus 65 would be 360. Right? Okay, and that's not a special angle, right? That's not 30 degrees or 45 degrees or 60 degrees. Right? So I can't tell you exactly what this cosecant will be, like I did with the earlier with this example here, when the reference angle was pi over 4. That's special, right? If the reference angle is one of those special angles, you can state what the exact value of the trig function is going to be. But if not, we can only really rewrite it in terms of the reference angle. All right, so the cosecant of 295 will be the cosecant of the reference angle, right, 65 degrees. And now we just have to think, is this positive or negative? Now remember, cosecant is the reciprocal of sine, and sine is related to y coordinates. Down here, y coordinates are negative in quadrant 4, meaning that the sine will be negative, meaning that the cosecant will be negative. So the cosecant of a 295 degree angle will be a negative number, and it'll be negative, whatever the cosecant of 65 degrees is. All right, and that's all they're asking us to type right here. Now let me verify that. Right, always check yourself. So again, I'm going to pull the calculator up. Now this time I'm in degree mode, so I'm going to go mode. Right, all my angles are in degrees here, and make sure I change it to degree mode. Right, you got to be really careful with this. So let's type in the left side, see what we get. Now remember, there is no cosecant button, but I can simply do 1 divided by sine, right, for cosecant, the reciprocal of sine. So 1 divided by the sine of 295 degrees is negative. I said it would be negative, right? It should be negative 1.1033 and so on. Now let me type in this other side. So negative sign, and then the cosecant of 65 degrees is 1 divided by the sine of 65 degrees. And this, if I did everything correctly, this better be the same value Oh, and look, it is. Great. So this is a true statement that I have written, and I can enter that into my assignment. Right, so again, we're entering negative cosecant of, and then the reference angle, 65 degrees, right? And there should be a degree symbol down here somewhere. Yep. Yeah, make sure if it's in degrees, you're putting the degree symbol, right? Because they didn't say don't put the degree symbol up here, right? And if it's in radians, you're not putting any symbols. Wonderful. Okay. So again, back on, still on the unit circle. All this is unit circle involved, and this is very similar to the problem I did earlier. Okay, but remember the problem I did earlier with the 15, you know, you had an x-coordinate of 15/23, and then used the Pythagorean theorem, and then you found the cotangent. Right? This is the exact same thing, except your angle ends at a terminal side that intersects the unit circle at a point with an x-coordinate of 4/15, right? 4/15 instead of 15/23. So I'm just going to cheat on this one and let you work through it. Okay, because it's the same kind of problem. Right. You find fill in the coordinates of that point, and then the cotangent would be the x-coordinate divided by the y-coordinate, right? If you're at a point on the unit circle. Okay, so this is similar. You know, I'll do this one just because it's tangent instead of cotangent. I'll write this one out. So it's determine the value of tangent of theta, given that the terminal side of angle theta intersects the unit circle in the first quadrant at, you know, a point with an x-coordinate of 9/10 and, you know, a missing y-coordinate. We're going to have to find that missing y-coordinate. All right, so back to my paper. Let's get rid of the calculator here. We'll use the calculator in a little bit, but so again, notice the repetitive nature of these problems. How I approach them is the same almost every single time. Right? So here's the unit circle. They said there was a point 9/10 for the x-coordinate. All right, so you got this, and we're in the first quadrant. It said we're in the first quadrant, because there's a point down here in the fourth quadrant with an x-coordinate of 9/10 as well, but we're only focusing on this point 9/10, comma, y. I don't know the y-coordinate of that point. All right. And there's an angle. They said, we have an angle. Now you can draw this angle clockwise or counterclockwise as long as it ends here at this terminal side. So I'll just do this angle here. This is angle theta. So hopefully, again, you see the right triangle formed here, right, by this dotted side and this horizontal. So this is 9/10, the x-coordinate. This is the vertical is I don't know the vertical. We'll call it y, and the hypotenuse is again 1. Right, every hypotenuse for these right triangles on the unit circle is just the radius of the circle. And I want to find that missing y. So Pythagorean theorem, right? 9/10 squared plus the y squared is equal to 1 squared, or just 1. This is 81/100ths plus y squared equals 100/100ths, right? Just getting a common denominator. So then y squared equals 19/100ths. If I subtract 81/100ths from 100/100ths, 19/100ths, and then y would be plus or minus, but because we're in the first quadrant, y coordinates are positive, so I'm not going to write plus or minus. I'll just do positive square root of 19, and then divided by the square root of 100 we saw is 10. So this y coordinate is the square root of 19/10ths, right? The square root of 19 in the numerator divided by 10 in the denominator. All right, now we're asked to find the tangent of this angle. And going way back to that first drawing I made, remember the tangent of an angle, if you're on the unit circle only though, right? 1 unit away from the origin. If the tangent of an angle is the y-coordinate of the point on the unit circle that you stop at divided by the x-coordinate. So the tangent of my angle here will be the y-coordinate of that point divided by the x-coordinate. The y-coordinate we just found was that square root of 19 divided by 10. The x-coordinate is 9 divided by 10. And if I simply multiply by the top and bottom by 10, the 10s will cancel. And I have the square root of 19 in the numerator, and then 9 in the denominator, and we're entering as a fraction. So the tangent of this angle that was drawn here is the square root of 19 divided by 9. And that's what we'll enter. I'll just hit the cheat because that's what's going to pop up. Let's see, square root of 19 divided by 9. Alright, let me continue on. Alright, so this is exactly the same kind of problem. Alright, so I've done 2 of these now. And again, just pay attention to what they want. If they ask for tangent of theta and you're on the unit circle, that's the y-coordinate divided by the x-coordinate. If they ask for cotangent, that's x-coordinate divided by y-coordinate. If they ask for secant, remember that's reciprocal of the cosine, the x-coordinate, so 1 over the x-coordinate. And if they ask for cosecant, that's the reciprocal of the sine or the reciprocal of the y-coordinate, right? 1 divided by y. So I'm going to just leave that to you. And again, you're going to see different problems with different numbers and stuff. So I've already shown you a couple of these. Alright, and then we have back to reference angles, right? So again, it's asking us to write the tangent of 71 pi over 36 in terms of the tangent of a positive acute angle. Alright, so rewriting it as the plus or the minus, and then times the tangent of the reference angle. Alright, so again, gonna do this, pull up some paper. Unit circle if we need it. Now we're asked about to rewrite the tangent of 71 times pi divided by 36 radians. Alright. So the angle I'm drawing here is 71 pi over 36. Now if you'd like, remember I can multiply this by pi over 180 over pi. I'll pull the calculator up and do this. If you want to get this into degree mode, if I take 71 pi divided by 36 and multiply that by 180 over pi, right, the conversion from radians to degrees, right? And 355 degrees, right? So this is 355 degrees. So we're trying to find the tangent of 71 pi over 36, or the tangent of 355 degrees. So let me draw that in. So again, standard position. So 355. I mean, once around is 360. So it's like so 90, 180, 270. Don't go to 360. It's too big. But it's it's only 5 degrees away from one all the way around. So we're here in quadrant 4 then, right? We're in quadrant 4. So there's theta, right? The 71 pi over 36. Theta prime is this angle here, right? Theta prime, the reference angle, is this small angle between the terminal side and the horizontal axis. And we just said that's 5 degrees. Right, it's 5 degrees, but we were given, our angle measure was given in radians. Right, our angle measure was given in radians. So I want to change this back to radians. So you can take 5 degrees, multiply it by pi over 180, and then simplify. Now I'm just going to do 5 over 180. Now basically how many times is 5 going to 180? All right, so I can do, I'm just doing on the calculator. I probably should already be able to tell you this, but so 30, it's pi over 36 then. All right, if I multiply this by pi over 180, 5 goes into 180 36 times, you'd have pi over 36. Oh, geez, that makes sense too, because 72 pi over 36 would be 2 pi all the way around. So 71 pi over 36 plus another pi over 36 would make 72 pi over 36, which is 2 pi. Once around is 2 pi radians. So I can re-express this now, right? The tangent of 71 pi over 36 is the tangent of pi over 36, right? The reference angle. Oops, let me get the calculator out of here, sorry. Is the tangent of pi over 36, right? The reference angle, and then I have to choose, is it a positive number or a negative number based on the quadrant that you're in. Now remember, in quadrant 4, your x coordinates are positive, your y coordinates are negative. And remember, tangent was the y coordinate divided by the x coordinate on the unit circle, right? On whatever point you're at on the unit circle. So if the y is negative and the x is positive, this is going to be a negative number for any angle that ends in quadrant 4 is going to have a negative tangent. So that's why I'm putting that, that minus sign there. All right, and 5 degrees is not a nice special number, right? It's not 30 or 45 or 60 or pi, pi over 36 is not pi over 6, pi over 4, pi over 3. So I can't go any further with this. I couldn't tell you what this is off the top of my head, but I still want to verify it. So I'm going to bring the calculator back and we'll verify that this statement is true. Now I'm still in degree mode. You can change back to radians, but it'll be easier to enter in degrees. So I'll just leave it in degree mode. Remember, this is 355 degrees. I wrote that over here. So I'll put in the tangent of 355 degrees. Oops, not 35, 355. And it should be negative, right? We said it would be negative. Negative 0.087, blah, blah, blah. That's the left side. Now I'll put in the right side. Negative the tangent of 5 degrees, right? Pi over 36 radians is 5 degrees. So negative tangent of 5 degrees, and it should be, if I did everything correctly, this should be the same value, and oh look, it is. Hooray. All right. So just again, I would verify your answers as often as you can. So this is what they want us to enter here, though, right? The negative tangent of pi over 36. So negative, tangent of, and then you got the pi symbol here somewhere, right? Pi divided by 36. And it should be in radians because the original problem was in radians, right? Submit that and it should be good. Right. I think there's one more that's, this is very similar. You just have to remember that your cotangent, and again, they might give you secant, they might give you cosecant, but you're doing the same thing. You draw the angle 5 pi over 9, right, which would be 100 degrees. Draw that angle, say, hey, what's the reference angle? So this will be equal to the cotangent of the reference angle, 80 degrees, or 4 pi over 9. And then, this angle, when you draw it, would be in quadrant 2. And the cotangent of an angle in quadrant 2 will be negative. So let's do this now. I already told you what it is. Again, after a while, if you do this enough, you'll be able to do what I just did out loud. All right, but I would recommend drawing it still. All right, so it'd be the cotangent of 4 pi over 9, and then negative because this angle 5 pi over 9 is in quadrant 2. All right. And that should be it. And again, just pay attention to whether or not they're saying secant, cosecant, tangent, cotangent. I know most of the examples I did in here was tangent and cotangent. But just pay attention, though, to if you have secant or cosecant being asked for. Right? That does change things a little bit. All right, so hopefully this was a good guide for you when you go through and do your own assignment. Your section 7.4 part 1 on your own. And obviously, if you have any questions, send them to me, let me know. And thanks for watching.